Shop the Plato's Closet Black Friday event in North Charleston and West Ashley and let the deals begin. You know Plato's Closet always has a huge selection of trendy recycled styles at amazing prices, but Black Friday deals are different. They're better. We've been holding back some of our best inventory, and you won't want to miss our Black Friday event. Save on gently used styles from Patagonia, Lululemon, Lilly Pulitzer, and hundreds of popular brands. Plato's Closet is ready to let the Black Friday deals begin. Plato's Closet, located in West Ashley on Sam Rittenberg Boulevard and North Charleston on Rivers Avenue.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello and thank you for joining us. This is the podcast we like to call Space Nuts. My name's Andrew Dunkley, your host, and joining me once again is astronomer at large, Fred Watson. Hello, Fred.
Hey, Andrew. Good to be with you again. It seems like a week.
It does. In astronomical terms, that could be any length of time, though, really.
That's right.
Now, today we've got a lot to get through. We're doing a series of double takes here. We're going to talk firstly about the Australian Space Agency. They've finally decided where they're going to put it, and that's because nobody wants to live there. The CSIRO's involvement in Voyager 2, which has made the news this week because it's finally left our solar system, technically speaking, but not the influence of the sun. It's very complicated. We'll get to that. The Chinese Chang'e mission, we'll give you an update on that, and the winds of Mars. We'll even try and let you hear them, which may not be easy, but we'll give it a go. And we've got a question going back to a podcast we did on Comet Wirtanen, the Christmas comet, they're calling it. This is the green one that should be visible fairly soon, if not already. Somebody's asked a question about the fact that it's surrounded in plasma. So we'll find out what's going on there. But first, Fred, the Australian Space Agency, where are they going to put it?
Well, so that was announced yesterday, our time, here in Australia. The Australian Space Agency will be located in the fine city of Adelaide in South Australia, which I have to say was not really a surprise to anybody, I think. Several other cities put in bids. I think perhaps one of the strongest came from Canberra, the federal capital. But Adelaide has a long history of connection with space because, of course, South Australia is the home of the Woomera base, which when I was growing up in the 50s was a household word. Woomera was where all the rockets were being tested, and it was a very exciting place.
And there are those listening overseas who haven't heard the word Woomera, it's actually an Aboriginal kind of weapon. It's used to launch spears to give them more velocity and distance. So
yeah, that's right.
Why it's called Woomera.
Indeed, that's right. And so that gave South Australia a head start back in the 50s and 60s. But there's also a strong contingent in the academic world in South Australia, as well as a lot of startup industries. But I think the thing that might have actually tipped it over the line, Andrew, is the fact that the first is he the first? He's certainly the Australian astronaut who has flown the most. Another Andrew, Andy
Thomas.
That's the man, yes, Andy Thomas, yeah. He's from South Australia, of course.
Yes, he is, yeah.
Yeah.
He was in this region a few years ago, and we got to have a chat to him on my former radio station, and lovely bloke.
Yes, he is. And in fact, that was probably the same time that he came and gave the lecture at Coonabarabran at the Siding Spring Observatory, which is thanks to Marnie, who made all that work. I'm only saying that because she just made a waving sound there to sort of indicate.
I heard that. It sounded like the winds of Mars.
Yes, it did. Yes, the winds of Mars. So it was a major a major coup for us to have Andy Thomas. But Andy is a passionate Adelaidean, and I think he wrote a very strong case in a document to say Adelaide should host the Australian Space Agency, and the government said yes.
Well, he knows his stuff, so I suppose he'd have a fair bit of influence. And so what form will it take? Is it just going to be an office block?
Yeah, pretty well. And not even that. I bet it's just a floor on an office, because they're employing a staff of 20.
Right.
So it's really an administrative thing. They have funds, about $41 million, to distribute in a way that will help to expand the Australian space industry. The figures are that the space industry worldwide is worth somewhere between $350 and $400 billion. These are Australian dollars. And we have a share of that, something like 1%. It's roughly something like $4 billion a year that's earned in Australia from the space industry. That's probably more than most people would expect, but it includes things like communications and satellite technology and lots of things of that sort. So that figure is hoped to be expanded by a factor of 3, so that within a few years we'll be talking about $12 billion. And that's the job of the space agency, to actually nurture those startups and, put everything in a common framework and hopefully turn it into this global player that Australia wants to be.
Which converts to about $120 US. It's exciting, and we've certainly got to get into this. Into this world, literally, the space race, because there are so many players that are involved now. You've got India, you've got China, you've got Japan, you've got all the big players, obviously. But it's the future. It is the future. We're not going to sort of stay here on Earth. We're going to start getting out there into the solar system and doing other things in time. So we really need to be a part of it.
We do, and we are, but we want to be a bigger part, of course.
Indeed. All right. Well, we'll watch the Australian Space Agency with interest, of course, and to let you know what happens next, what sort of floor tiles they choose, that kind of thing. Very exciting stuff. Now, let's move on to something that's super exciting, because I was a kid when this all started. And, of course, now, 41 years down the track, Voyager 2, which I'm told was launched before Voyager 1, has left the solar system and has entered interstellar space. And there's an Australian connection to this story as well.
Very strong one, that's right. So you're quite right. Voyager 2 was launched on the 20th of August 1977, and it was just over a fortnight before Voyager 1 was launched. But that means that Voyager 2, I think, is it may even be the oldest space mission still operating. Actually, I'm not quite sure about that, because the Pioneers predated it, and they too are leaving. Pioneer 10 and 11 are also leaving the solar system. Voyager 2, absolutely epic mission. It's basically told us much of what we know, or certainly what we knew in the second or the last quarter of the 20th century about the gas giant planets, Saturn, Jupiter, Uranus and Neptune, but not necessarily in that order. So those planets were first explored in detail by the 2 Voyager probes. Voyager 2 took in them all, actually. It was the Grand Tour mission, which was basically dictated because of the alignment of the planets at the time. But now, as you say, it's leaving at least one component of the sun's influence. So it's going through what's called the heliopause. And the heliopause is that boundary between the area that's dominated by the sun's magnetic field. And when you cross that, you're in a region that's dominated by the magnetic field of the galaxy, the interstellar magnetic field. And you can sense this with plasma detectors and with magnetometers and all of that sort of thing. That the spacecraft are still both functioning. They're sending data back to Earth. They have power supplies that will probably go on for maybe even another 15 years or so. They are little nuclear power plants. And so we know that the magnetic environment has changed and Voyager 2 has crossed the heliopause. Now, just to temper that slightly, Voyager 1 which is further away because it moved faster, that crossed the heliopause, I think, in 2012. But it crossed it a number of times because the heliopause is a movable feast. It's something that, changes its shape. And so 1 minute you're inside it, the next minute you're outside it, the next minute you're inside it again because it's swelled a bit. And so there was a period when this crossing was not something that happened on one day. It took a period of months before Voyager 1 was definitely outside the heliopause.
And when that sort of happened, they picked up some anomalies in the telemetry, didn't they? And they didn't really understand what it was at the time, and then they put two and two together. Is that how it happened?
Are you thinking of Pioneer 10?
Oh, maybe it's Pioneer 10.
Was in the wrong place.
Right.
And that was eventually solved. That's another can of worms that we won't open up. But yes, there was the thermal properties of the spacecraft were not properly accounted for when they were looking at its orbit. So it actually had accelerations that hadn't been taken into account. And it wasn't that our understanding of gravity was going on. Just talking of gravity, though, that's a point I wanted to make in that, yes, it's crossing the heliopause, but that doesn't mean it's beyond the sun's sphere of influence, because the gravitational pull of the sun is still being felt by the Voyager spacecraft and extends much, much further away. And in fact, some of us would think of the boundary of the solar system as being the Oort cloud. The Oort cloud is a cloud of comets, proto-comets, it's where comets come from, which is at a much greater distance than the Voyagers are, and almost kind of halfway to the next nearest star. Voyager 2 is 16 light hours away, or about 18 billion kilometres. And why is there an Australian connection to the story? Because Voyager 2 is heading south. It is actually leaving the solar system, but south of the plane of the solar system. So that means it's south of the Earth's equator. It's a region which is inaccessible to the big radio telescopes in the northern hemisphere. And so the Parkes radio dish in Parkes in New South Wales and the Canberra Deep Space Communication Complex at Tidbinbilla, they are where the signals are coming back from. So it's a strong Australian component.
Indeed, yes. When we're not playing cricket in the dish, we can listen to Voyager, which is fantastic. And it's just been one awesome mission that has lasted a lot longer than I'm sure anyone anticipated, and still getting signals, still getting information, still learning so much from what was actually an afterthought. These missions were sort of something that came up in a back room by one bloke who went, hang on a minute, we can do this, and voila, there it goes.
Yep.
All right, you're listening to Space Nuts. Andrew Dunkley here with Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Next up, Fred, we're going to look at the latest with the Chinese Chang'e missions, Chang'e 4, which is headed to the far side of the moon. Where are things up to? I notice it's made the news this week.
It has, yeah. That's because the spacecraft has now been launched, so it's now on its way to the moon. I think it was launched nearly a week ago, end of last week sort of time. It is not on a rapid trajectory to the moon. It will not land on the surface until the end of January, so it's got a fairly leisurely progress that is being followed in the meantime. But of course, this mission is very interesting because it's the first lunar lander that will touch down on the far side of the moon, and it's going to a really interesting place, the South Pole Aitken Basin, which is near the South Pole of the moon. It's a big dent in the lunar crust, probably caused by an impact in the very early history of the solar system. And so, it's possibly a place where there might be really interesting minerals and all kinds of evidence of what happens when you get a big impact of that kind. So it will touch down, as I said, at the end of January. As you and I have discussed already, it already has a communications satellite waiting for it. This is a spacecraft in orbit around one of the Lagrange points on the far side of the moon. So it is in orbit around nothing, but that is in such a trajectory that it can always relay the signals to and from Chang'e when it is on the backside of the moon and sheltered from or shielded from terrestrial radio interference. And that's one of the reasons for going there, actually. The spacecraft's mission is partly to characterize what's called the radio environment on the far side of the moon. In other words, check how radio quiet the far side of the moon really is, because that one day might be the location of a major radio astronomy observatory. You've got the most radio quiet place in the locality of the Earth. The Earth is beaming out radio signals very copiously, but if you can get rid of them all by putting the moon in the way, then it's a good thing. But the other thing that I like is it's carrying a lunar mini biosphere experiment, which consists of seeds to try and grow potatoes.
I wonder where they got that idea.
I'm sure they found it from somewhere. And something called Arabidopsis, which I think might be cress. I'm not sure about that. Do you know that?
I've heard of it, but I couldn't tell you.
Yeah. So it's about the study of the respiration of the seeds, the way they breathe, and photosynthesis, the way they turn light into energy on the moon. That's the experiment director speaking to the Xinhua news agency. So it's very, very interesting. I mean, one of the issues on the moon is this huge range of temperatures. It's something like minus 170 to plus 130, or is it the other way around? I can't remember. It's an enormous range of temperatures, whereas the mini biosphere has to remain within the range of 1 to 30 degrees, and that's going to be a bit of a challenge. So I think they'll basically have quite an interesting experiment on their hands, and I look forward to seeing what the results are.
Yeah,
so it's
very exciting. I'm glad, and as I said before, with all these new players, here's one doing something extraordinary and something that hasn't been done before. And of course, they're not going to quit there. They're looking at Chang'e 5 next year, I think. So they're going to keep on keeping on. I think they're still planning to put people on the moon, the Chinese.
Yeah, that's the long-term plan. Yeah, Chang'e 5 and 6, I think, are designed. So these are the next ones in the sequence. Are designed to bring back samples of lunar rock and soil here to Earth.
Yeah, never been done before. No, of course. Did I tell you about that story where each state in the US got a piece of moon rock from the Apollo missions, and they've lost some. So they've started a nationwide search. Well, a state-by-state search to see if they can.
And you find out dirt.
Yeah. Yeah, where's me rock?
Yes.
Now, we're going to move straight along to another fascinating place, and my favourite place in the entire universe, if not, the entire universe. Let's just leave it at that. This is Mars. And, of course, Mars has been in the news because, the InSight lander has done exactly that, landed and started sending back some really interesting stuff, Fred.
Yeah, so you remember we spoke about this in some detail a few weeks ago. The InSight lander is really designed to probe the interior of Mars. So one of the instrument packages it carries is a seismometer to measure vibrations in the surface of Mars. That has not yet been deployed, though. It is still on the spacecraft. It will be deployed, I think, in about a month or so, when they've worked out what the best place to put it is going to be, to pick up the sounds of Mars. But meanwhile, it's still on the spacecraft, and it turns out that it's listening to the wind on Mars. The seismometer experiment is led actually by Professor Tom Pike from Imperial College in London. And he's made the comment that the solar panels on the lander's sides are perfect acoustic receivers. So they sort of vibrate slightly as the wind, the Martian wind passes over them. And because the seismometer is still on board the spacecraft and not deployed on the soil, it listens, it can pick up the sound of the solar panels.
Was that unexpected?
Yeah, it might have been. Yeah, it probably wasn't unexpected, but it's probably not something that was shouted about too loudly.
Just in case.
Just in case it didn't work. But we now have recordings of this because we've, this has now been broadcast or issued on the airwaves of the internet, if I can mix my metaphors grossly there.
Why not? But look, I'm going to try and share that sound with us now and hope that it's loud enough to be picked up. So here we go. This is the wind of Mars. So that's what it sounds like. Sounds like wind.
It sounds like the digestive processes of a wombat to me.
Well, I was listening to that too and thought that they must have had a Martian rabbit or something nearby chewing on some cress because it certainly had that munchy sound about it. But that's what it sounds like.
It's great. We have to, give the disclaimer that they've lifted the tone by 2 octaves to make it audible because I think it's fairly low frequency sounds that we're hearing there. But they've been lifted, and it's a really interesting thing. I think what's even more interesting is going to be when these seismometers, or when this seismometer is placed on the surface and we start hearing the sounds of Mars itself.
Yes, and measuring the movement within the planet, which is something they're looking for, the seismic activity or whatever is happening beneath the surface. We just still don't know really what goes on inside Mars. We're still learning about our own planet and what it's doing. Yep. So it will be very exciting once they get down and dirty, literally, with the planet Mars through the InSight project. So we'll keep an eye on that. But it's quite exciting and fascinating to be able to see and hear what's happening on other places, other planets, which we've been able to do over the years with the technology advances. I can imagine in the early days when they were first looking at pictures coming from Mars and pictures coming from Venus and that sort of thing, it must have just been mind-blowingly thrilling.
I think it was. I think it still is, though, Andrew.
Oh, yeah. I mean, this is a whole new wave of information, isn't it? Okay, we'll get back to that because there'll be a lot to tell in the future about what's happening on Mars through InSight. You're listening to Space Nuts with Andrew Dunkley and astronomer Fred Watson.
0G and I feel fine.
Space Nuts.
Now, Fred, to an audience question. This one comes from Andrew Mitchell. Hi, Andrew. Thanks for sending us your question. He was listening to a recent episode where we were discussing the comet Wirtanen. Now, he says, Fred made an offhand comment that the coma of the comet is a plasma. I was very surprised by that. I'd always assumed it was just dust and water molecules boiled off the comet by radiation of the sun. Obviously, there's something new for me to learn, and I'd love Fred to explain more about the coma and what creates it and what it is. Thanks so much. Oh, P.S. I fully expect that you'll both be doing the show in 5 years and that I'll be listening as soon as it comes out. Keep up the good work. I didn't know it was good work, but thank you, Andrew. Appreciate it. And I hope we are too.
Yeah.
But
Me too.
yes, the coma, plasma, what's going on?
So that's right. So essentially, exactly, exactly as we've heard in what you've just read out, the comet is basically an icy object which is laced with dust. And when it gets near the sun's radiation influences it. And the bottom line is that the ice sublimes into a gas and the dust is released. And so you get actually this coma. The coma is the word means hair. It's just like gives it a hairy head. The coma is the fuzzy bit that surrounds the nucleus of the comet. It's what you usually see. The tail is the coma that's being blown away by the radiation pressure of the sun. And what happens is that the sun's radiation, in particular the ultraviolet light from the sun, and also to some extent the subatomic particles that come from the sun, they start knocking electrons off the atoms that are making up this gas. And in particular, most of what's coming off is H2O. It's the ice turning into H2O vapor. So there's this sort of photodissociation, it's called, that separates the atoms into hydrogen and oxygen, and then you start getting the electrons knocked off to ionize these materials, these elements, and that is basically what a plasma is. It's an ionized gas, and so the tail itself is pushed away, sort of, by the solar wind. It's probably the solar wind plays a role in the fact that the tail of the plasma points in a different direction from the dust trail. That's the point I'm trying to make.
Okay.
Some comets have two tails.
Yes.
One of which is the plasma tail being pushed away by the solar wind. The other is the dust tail, which is just being left behind, basically.
Right.
And they're both illuminated. The dust tail is illuminated by the sun in the same way as what we call the zodiacal light. That's the light caused by dust particles between the planets, which you can sometimes see after sunset or before sunrise. So the two tails are formed by different processes, but ionization is certainly an important process. Just as a footnote to that, there were some interesting experiments done, carried on board you remember the Rosetta spacecraft that investigated Comet 67P,
Yes.
Churyumov-Gerasimenko, which you and I talked about at great length. The University of Uppsala in Sweden had a plasma experiment on board that, which I think did a lot of work on looking at the complex structure of the plasma coma, because it's not a simple thing. We tend to think of these things in fairly black and white terms, but actually there are real subtleties about this. Maybe I can just read that, because it says the department in Uppsala contributes one of the instruments on board the Rosetta orbiter, a kind of weather station known as a Langmuir probe. Together with other instruments in the Rosetta Plasma Consortium, we investigate the ionized component of the gas oozing out of the icy nucleus, how it interacts with the dust from the comet and the ever-changing solar wind. At other comets, the environment is known to structure itself into several regions with different properties. From Rosetta, we are already learning that this picture is very simplified as we follow how the comet environment changes with distance to the sun.
Okay.
So it's complex stuff, but very interesting. And just a footnote on Wirtanen, it's We are approaching the time when it's, in fact, I think yesterday it was at its closest to the sun. That's the 12th of December. It will be closest to Earth on the 16th of December. Unfortunately, the moon's getting pretty bright, but it is going to be worth a look if the skies are clear. I had a look last weekend with binoculars, and I did find the comet, but it was incredibly faint. It was very, very difficult to see, certainly nowhere near naked eye brightness. Partly that's because its coma is relatively large. It's the size of the full moon in our sky, but it's very diffuse. So I could only see it in the binoculars, and these were reasonably decent binoculars, 7 by 50. I could only see it by averted vision, which means you look to one side and the more sensitive part of your retina sees the faint image of the comet.
Ah, okay. Well, there's a handy tip for anybody who wants to try and have a look at it.
Yeah.
Because everyone tends to just look directly at things.
That's right.
And sometimes that's not good enough.
Not the best way. It is not that easy to find. You need to go online and check. There are many finding charts or finder charts to let you see exactly where to look. I was looking in what I knew to be the right place, and sure enough, I did find it, but it was very, very faint.
So, in a few days, how visible will it be for people?
It'll be much the same. It will be brighter, I think, but it will not be glaringly obvious in the night sky.
Okay, so without binoculars, you'd be struggling.
Yes, I think so.
All right. And if you're lucky enough to have a telescope, great. That's even better. All right, Andrew, thank you for the question. I hope we covered the answer for you adequately. And got another email during the week I want to share. And all jokes aside, we do love it when we get a bit of feedback that just makes our chests puff up a bit. And this one came from Patrick Healy. Thank you for making this podcast. I truly look forward to it every week. Just wanted to let you know. That's lovely, Patrick. Thank you very much. We appreciate it. It inspires us to make one more episode.
Or maybe two more.
Maybe two more. We'll keep going. Fred, thank you so much. It's been a pleasure as always.
Great pleasure to talk, Andrew, and we'll speak again soon.
We will indeed. Astronomer at Large, Fred Watson, and from me, Andrew Dunkley, thank you again, and we'll catch you next time on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.